Hello, welcome back to Chemistry Tutor with Tam. Last video we discussed on Introduction to Organic Chemistry. Now we'll be dealing with types of hybridization. Hybridization simply means mixture. In a layman language, hybridization simply means mixture. For example, when you mix salt and water together, you form a mixture. You mix sugar and water together, a mixture is formed. Similarly, the same way we mix salt and water together or sugar and water together to form a mixture, hybridization has to do with mixing of orbitals. We have the S-orbital mixing with what? P-orbital, forming hybridized orbital. So similarly, we consider two atomic orbitals, which are the x orbitals and the p orbitals, and when you mix two type of orbitals together, the new orbital formed is called hybrid orbital. Dumbbell, the shape of s orbital is what? Spherical, while shape of p orbital is dumbbell. We mix it together to form a shape which is called the hybrid orbital, the mixture of dumbbell and what? Spherical shape. Therefore, the standardized definition of hybridization is when you mix two atomic orbitals of the same or nearly the same energy to combine together to form a new orbital. Importance of studying hybridization. The two main importance of studying hybridization is molecular, geometric, and what? Bonding of orbital. The hybridization has to do with explanation on how orbitals are being bonded. For example, hybridization is the mixing of orbitals. So hybridization is telling us the bonding of orbital, and molecular geometry is talking about the shape of the orbital. Through the hybridization, we can determine or deduce the type of shape of a particular orbital when it is mixed. For example, why are atomic orbitals hybridized? The reason why atomic orbitals are hybridized is we have b atom having only s orbital, and a atom having s and p orbitals, and b atom having only s orbitals. Now the atom A reacts with two atom B. Now we have two b atom and one a atom. The b atom having x orbital, the a atom having s and p orbital, and the atom having only s orbital. Now when they react, the s orbital here will come and react with what? The p orbital here, and the s orbital here will come and react with what? S orbital here, which is not possible. That is, we cannot react it directly. Now because the reason why it's not possible is that a particular atom cannot have two different orbitals. So we have to mix this a atom having s and p orbital, we have to mix the x and p together first, so making a having what? Sp, making a having what? Sp. So then the b orbital will now react with sp of a at the left hand side, and the b orbital here will react with what? Sp of what? A. So now when we react, we have what? SSP orbital. We also have what? SSP orbital. Unlike this, the first one, which says that the s orbital reacting with p, we have sp here, and the other side we have what? SS, and it's not possible. We have to have the same thing at the right hand side and the same thing at the what? Left hand side. That is why we have to mix the s orbital here and the p orbital here together first before we now mix it with any other orbital. Now note, hybridization does not take place in every molecules, such as hydrogen chloride, and what? Hydrogen sulfide, and other examples. Hybridization does not take place in all molecules. Now we'll talk about the types of hybridization. So we have the types of hybridization. We have 7 main types of hybridization. We have the sp hybridization, giving a geometry. Another word for geometry in chemistry has to do with what? Shape. So geometry, that's the essence of hybridization in chemistry. It has to tell us the shape of what? Of the orbitals being mixed. So we have s and p orbital giving us linear shape, s and 2p orbital giving us trigonal planar, s and 3p orbital giving us tetrahedral, s and sp3d giving us trigonal bipyramidal, sp3d2 giving us octahedral, sp3d3 giving us pentagonal bipyramidal. We have dsp2 giving us square planar. What it means is that for s to form a linear shape, we have one s, you mix one s orbital and one p, giving us linear. Here we have mixing of one s orbital and two p, giving us what? Trigonal plane. And for the tetrahedra, we have one s combining with what? X plus 3p. Here we have x plus 2p. Here we have x plus only 1p. Here we have s plus p, 3p, and d to give us trigonal pyramidal. But for the tetrahedra, we have one s, you mix one s, 3p orbital, three different p orbitals, and what? Two d orbitals, giving us tetrahedra, and so on and so forth. That's how the mixing is being done. In my next class, we'll be talking on three types of hybridization, which are sp, sp2, and sp3 hybridization. Don't forget to subscribe to this YouTube channel and watch out for my next video. Thank you.